is Richard Kelly, and thank you for being willing to move forward to this time slot in the Department of Geography. So quite a different angle here. New territory, so to speak, right? The topic is Imaging Research in Geography, Earth Observation and Remote Sensing Applications. Welcome.
Thank you. Okay, so it's kind of interesting coming into this crowd because when I think of high spatial resolution, I tend to think of maybe less than 10 meters, whereas you guys are looking at the molecular level among other scales. So bear with me. I just wanted to give really just an overview of the kind of imaging that we do. I think the key here is that we are imaging to try to understand Earth system processes, really. I think there's a statistical element of the imaging itself, but the measurements that we make, what we're trying to do is to understand Earth system and environmental system processes. In the geography department, and I guess in the Faculty of Environmental Studies, we are currently undertaking research and teaching in geomatics. So that, to us, that consists of remote sensing, Earth observation, geographic information science or geographic information systems, and also geodesy and surveying. So you're looking, we're interested in data acquisition from the geodesy, surveying, and the remote sensing element, and then the geographic information science does the analysis for us to get at those processes. And the kinds of Earth and environmental system processes we're interested in, I think, mostly from a remote sensing point of view, are physical process systems such as hydrology, terrain modeling, looking at digital elevation models and how they impact on geomorphological processes. And also, when you take it onwards towards policy, you're interested in land and resource management. So to give you a sense of the kind of remote sensing Earth observation scales, I guess from global to local, and local again is not the micro, it's the 10 to 100 meter scale. But I've actually just come from NASA, where I was working for the last 5 years. The slide on the left shows you a product that I currently manage for them. Is a global snow water equivalent product. This is a product that uses a satellite instrument in the microwave part of the EM spectrum. These are passive microwave measurements of the order of about 10 to 20 kilometers. So footprint spot sizes of that order. And what we do with these is we take swath data, granule data, stitch them together for a whole day, and the microwave signal is sensitive to the amount of liquid water in a column of snow. So we can do some algorithmic work, and the algorithm, I suppose, at the moment is semi-empirical. It uses some statistical analysis, but it's based on physical processes. We can take it to the other extreme and do physical modeling of the electromagnetic response and the microwave response if we want to. But on an operational implementational perspective, we tend to take the semi-empirical approach right now. But this sort of a product is the sort of thing that NASA does really well, and you know, there are all sorts of research issues with that we're plowing through these days. That's a snow example. Here we have a sea ice example. This sea ice anomaly map on the right-hand side, actually, I don't know if some of you may know this, but there is something called the Canadian Cryospheric Information Network here at the University of Waterloo. We have 2 or 3 full-time scientists who are collecting data on cryospheric data for Canada and high Arctic. And with International Polar Year coming up soon, we're trying to position the University of Waterloo in a central place as a data repository. So the kinds of data sets, these two represent the kind of large-scale process data sets that we work on and we archive. Why is that important? Well, one of the reasons that we're interested in this is for climate change type analysis. So in fact, the top figure is taken from some colleagues who are working more on the infrared visible part of the spectrum. These are snow maps that's been put together for a one-season movie. And the nice thing about working with people at NASA still is they have a lot of visualization capabilities. But it's something that I could see an imaging group here being really useful to help develop locally. Maybe compete with NASA for something like this. That would be a really cool thing to do. The bottom what looks like a nice sinusoidal plot actually is a trace of snow cover extent running from 1979 through to 2003, so northern hemisphere satellite-derived snow cover extent from 2 different instruments. And the sort of work that we're interested in is trying to figure out what is the difference between the observations for one sensor, the pink one, and the observation from another sensor. So those are global scale. Coming down to regional, local scale measurements, we also work, we've done a lot of work in spectrometry using hyperspectral instruments. Here we have a graduate student working, I think this one is the top one is in Palau, looking at coral reef systems, and down here looking at crop systems, looking at the spectral response at over hyperspectral measurements. The instrument that's being held here is a ASD personal spectrometer. It has about 60 bands, or 60 or 70 bands of wavelength measurements, which gives you a very detailed characterization of a target you're interested in. If you scale that up to the local scale, this is an aircraft flight line using the CASI spectrometer, which is again about, I think, 70 or 80 channels, something like that. And for this kind of work, we have to do all the registration, co-registration with other passes. But we also are keen to figure out for land inventory what's actually there and how it's changing. So global, right the way down to local scale problems. And then some of you may have seen this. We were fortunate enough to work with Optech earlier this year to get them to fly an aircraft LiDAR instrument over the university. So here we have very precise height measurements from an aircraft I think it was around about the end of March, early April. The university, the main campus is here. I guess we're in a building somewhere up here. And there's a perimeter institute down here. We've had some interest from people at IQC trying to figure out precise distances and heights from here up to one of their buildings up here by by RIM. So there's lots of scope for collaborating with others on some of these precise local scale measurements that we make. We also have a new initiative just beginning with, I think the department well, the faculty and the department has been through some reprofiling in the last couple of years, and we're just beginning a new program in geomatics. So we're looking to ramp up on the actual teaching side. So we have anybody who's interested, come and see me afterwards. And if you want to find out more about what's going on the Earth observation remote sensing side of the campus, we're having a 13th of July, put it in your calendar. We're having a day where we've asked people from all over campus who are interested in, who do this for research to come and give an overview of what they're up to. So we've got land surface processes, terrestrial ocean cryospheric science, atmospheric chemistry, and coral reef systems represented. So come and find out some more if you want to. Thank you.
So questions. First one is the obvious one. Is there global warming?
You really want me to answer that?
Not a chance.
Is there a need in global approaches to go beyond that scale of tens and hundreds of meters, or to go to get a finer resolution?
Yeah, I think that's one of the interesting things in the remote sensing community now is that many of the new instruments that are being developed are being pushed by the scientists. I think it's fair to say up until probably the early 80s, mid-80s, there was a technology pull. The engineers said, we've got this instrument, who's interested? And you kind of get you get some really good stuff done. If it matches your application, fantastic. If it doesn't, you work with what you've got to try and answer the question you have. I think in the last 10 years, ESA, NASA, CSA have been very much proactive in getting scientists in with the engineers to specify exactly what is the best measurement that you need to address some of these questions. And I think you're seeing that with some of the instruments now that are being launched. So scale is coming down. I mean, everybody wants to be able to map everything very, very frequently and at very, very high spatial resolution, but there's costs.
Eric and then.
One of the most interesting things I've seen for a long time is Google Earth.
Right.
Is there a cost to sort of expand that kind of information data set so that everyone has
That's something that CCI is looking at the moment. In fact, the National Snow and Ice Data Center in Colorado has a mechanism. I think you have to develop there's an intermediate file that connects Google Earth to your local data set, a KMZ file. And that will do it if you set your data up in a way that Google Earth can do. So if you go to nsidc.org, you'll see an example of where they've taken some of their local data sets and they drape them over Google Earth and you can fly around. And we're looking at doing similar things, yeah. The great thing, Google Earth, I think, is one of the things everybody is out there looking at it, so it's a great thing, but there's a lot of things it doesn't do that we could hopefully push as well.
Okay, Ed?
Oh, I just had a dumb question. What is geomatics? Is it like geographical informatics? Or what is geomatics?
Geomatics, I think the conventional wisdom, and Canada seems to have a strong hold on that term. Coming from the UK and from working in the States, it's not looked in quite the same way, but I think geomatics, it encompasses data acquisition, data correction, and imaging. I'm putting imaging with all of this as well, data collection, and then data analysis as well. So you have remote sensing and GIS and surveying. So if you go back to that very first one, where those are the three areas that we're interested in. So it's measuring the Earth, geomatics. So.
Okay. Back.
You mentioned there was interest in resolution enhancement using improvements in the hardware technologies. Is there also interest in using image processing algorithms, image processing through a real push?
Yeah, I think so. Yeah, I mean, I think the reason that I tend to not use the word imaging, because from a remote sensing point of view, people think of pretty pictures. If you think about the measurement process that goes into making those images, then yes, you then get into using software image processing to enhance your measurement capability. One of the things with many remote sensing sensors is that there's a lot of overlap between measurements. So if you have a scanning instrument that's picking out spots, the overlap allows you the ability to do some post-processing and enhance the resolution. So yeah.
Thank you very much.